Okay, so welcome to section 3.5, proving lines parallel. This section actually would be probably better served to come after 3.2 because it relates to a bunch of stuff back to 3.2, but I think the book wants to kind of give you a break on those angles for a bit, go to some algebra, and then come back to some geometry. But anyway, 3.5, we're going to prove the lines are parallel. What we've already done is we've found slopes and lines and used them to identify parallel and perpendicular lines. Now we're going to go use some theorems and angle pairs that tell us that. So the first thing is this, and this is the kind of like it was in the beginning of section 3.2. Two lines are parallel if they're cut by a transversal, so their corresponding angles are congruent. Okay, so if two lines are cut by a transversal so that their corresponding angles are congruent, then we can say the lines are parallel. This is the converse. Remember the conditional. I'll just type this out to make it easy on myself. Conditional says if P then Q. Well, we already had one that said if lines are parallel, then the corresponding angles are congruent. Now we're going to flip that. We're going to say, hey, if Q, then P. Okay. So that's why this is the converse. Real quick, I can actually just pull this up. I got time. This is a short note. Back in section 3.2. Okay. Computer's not moving very fast today. Here we go. In section 3.2, 3.2 notes, we had the corresponding angles postulate. If two parallel lines are cut by a transversal, that was our P. Then each pair of corresponding angles is congruent. That was our Q. Now we're switching it around to the converse. If two lines are cut by a transversal, so the corresponding angles are congruent, there's Q. Now we know the lines are parallel. That's P. Okay, so it's really the same thing. You almost could, make them one big giant theorem or one big giant postulate, but the book splits them up, and it's traditional to do that. Now, the one postulate or theorem that might be weird to you is this one then, or one postulate. Sorry, if given a line and a point not on the line, there exists exactly one line through the point that is parallel to the given line. Now that's a lot to unpack in words, so I'm going to kind of do some drawing here. So this is all that's saying. Hey, you've got a line out in space. Okay, a straight line. And you've got some point that's not on it. Okay. All the parallel postulate says is there's only one line you can draw through this point that would also be parallel to the other one. Which again, hopefully kind of makes sense. If somehow I could draw more than one parallel line, like this line, well actually they're kind of poorly drawn, they'll eventually intersect somewhere out here. But let's imagine for a moment they're parallel. If I could somehow draw another one that's a different line that's parallel, that's weird. So that just means that our lines are straight, basically. It means like we'd have to do curve stuff. If I said like, no, this line's never going to intersect either, and I consider that a line, that would be craziness, and we don't want to mess with that. So the parallel postulate is just trying to give something that hopefully seems pretty obvious, a little more strength behind it. Now the rest of the theorems in this section are again theorems we've seen before, just in their converse forms. So theorem 3.5, instead of saying if lines are parallel, alternate exterior angles are congruent, we're going to do the converse of it. If two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then the lines are parallel. Okay. 3.6, consecutive interior angles converse. We said in 3.6 that if lines are parallel, then the consecutive interior angles are supplementary. Well, now we're going to flip it and say if they're supplementary, then the lines are parallel. So if two lines in a plane are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the lines are parallel. Okay. 3.7, alternate interior angles converse. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. And again, before it was if it's parallel and the alternate interior angles are congruent, then then they're congruent. Now we're flipping it. If those guys are congruent, we know the lines are parallel as well. The last one, I like this one. This is a good theorem. Basically, in a plane, if two lines are perpendicular to the same line, then they're parallel as well, which just works out because if I kind of point to these two angles here, where the right angle is, that angle, and that angle, they're a pair of corresponding angles. They're just a specific congruent pair. They're right angles. So in a plane, if two lines are perpendicular to the same line, then they're parallel. Okay. And then basically, a lot of our stuff here is just kind of going through and doing problems we've already kind of done before, but with a different mindset. The idea this time is, oh, I'm not going to, I don't know they're congruent to begin with, or I don't know they're parallel to begin with. I want to say, how would I know they're parallel? Okay, so here we are, 1 through 4, okay, in the video. I'll go to their sheet here. So given the following information, determine which lines are parallel, and then state the postular theorem that justifies your answer. All right, so for number 1, we're told that angles 1 and 3 are congruent. So here's 1, here's 3. Okay. So we have to figure out is, first of all, what transversal are they on? And it's easy to identify the transversal because the transversal is the line that both of those angles touch. So it touches this angle's formed by this line and this line here. This angle's this line and this line. Oh, so the transversal's L. And then the question is, what two lines cross that transversal? Well, J and K. Okay. So now we've identified what lines we're going to probably be parallel, even though you can hopefully see it, but just our justification for it. And then we know, oh, these angles here are the two that are congruent. So the question is, what type of angle pair are they? Well, out of the groups of 4, they're the top left of both of them, and they're in the same position. So they're corresponding angles. So 1, we would say J is parallel to K. How do we know that? The corresponding angles converse. Okay, and you have to say converse. You just can't say corresponding angles. This is a different statement. Corresponding angles converse says if they're congruent, the lines are parallel, and that's what we're saying. Okay. And number 2, okay, angles 2 and 5. I'll do this in a different color so that they kind of stand out. Angles 2 and 5. Well, oh, here's 2, here's 5. Okay, again, they're actually both on transversal L. They both make part of JK. And this time, they are alternate interior angles. So J is parallel to K by the alternate interior angles converse. Okay. Let's see here. Number 3. I'm kind of running out of room here. I keep drawing over the same things. Number 3. I'm talking about angle 3 and angle 10, and those guys are congruent. Now angle 3 is this angle here, angle 10 is this angle here. K is their transversal. It crosses L and M, so 3L is parallel to M. Now the question is just, what type of angle pair are they? Oh, well, this is outside L and M, and they're on opposite sides of K, so they're alternate exterior angles, and again, converse. The theorem we did in 3.2 proved the angles were congruent because the lines are parallel. In 3.5, we can say the lines are parallel because the angles are congruent. And then last but not least, number 4. Number 4, 6 and 8 are supplementary. It doesn't say that, but that's what we're saying. Since we say they add to 180, oh, that means they're supplementary, which should give it away, but let's just justify it. Oh yeah, 8 and 6, they both meet on line K. Okay. So L and M are their parallel lines we're looking at. And they're consecutive interior angles, so it's the consecutive interior angles converse. Okay, great. All right then. Let's see what's in the video next. Okay. That's what I thought. So, number 5, short response. So here we go. So for your homework, okay, your problems are to solve for x so that m is parallel to n. Okay, so I'm not going to tell you how to do it, but here's what I want you to do for number 5. I want you to, first of all, identify what type of angles they are. Let me extend this out. And then 2, solve for x in the problem. Okay. And then in class tomorrow we'll talk about this, and again you'll have some problems to work on, probably group work wise, just depending upon how the lesson goes, and then we'll spend the day talking about it. Okay, great, thanks.